So question 29 to 32 says, match the graph with the function based on the end behavior model. So we want to know what's really happening to these graphs as the limit as x goes to infinity. Now we're going to do this kind of roughly, then I'll show you how we can do this a little bit more concisely with long division. But for 29, if I took a look at this limit, I'm going to take the limit as x goes to infinity of 2x cubed minus 3x squared plus 1 over x plus 3. We basically have a cubic divided by a linear function. Now, roughly speaking, I know that those two terms, when they divide out, are going to give me the behavior of this function. So it's going to behave approximately like a 2x squared function. So looking at this, I can see that the 2x squared function best matches this function here. It's a parabola and it's facing up. Okay. Now, if I want to do this more concisely, and for this problem we don't really need to, but if I want to know what this more concisely, what I could actually do is I could do my long division. And I could divide x plus 3 into 2x cubed minus 3x squared plus 0x plus 1. And by doing this, the numerator is going to give me the end behavior. So 2x squared, and I can subtract this. I get a negative 9x squared plus 0x. So this is going to be minus 9x. So this is going to give me 27x plus 1. So plus 27, I'm going to end up with 27x plus 81. That's going to give me a remainder of negative 80. And in my division statement, it's going to look like this. My f of x, equivalently speaking, is going to be 2x squared minus 9x plus 27 plus my remainder of negative 80 over my divisor of x plus 3. The limit of this function, well, this piece is going to tend towards 0. So we can basically ignore that. And then as x gets really large, it's going to behave like this 2x squared minus 9x plus 27 parabola, which is going to match a. So for 29, we're going to match a. Now again, we didn't need to do all this analysis, because if we just take a quick look at this and just compare the highest power in the numerator and denominator, we can see it's going to behave like a 2x squared parabola. So then we could do the same with the other ones. We're going to do, so this is 29. Number 30 looks like this. The limit as x goes to infinity of x5 minus x4 plus x plus 1 all over 2x squared plus x minus 3. Okay, just going to clean that up a little bit. So it's 2x squared plus x. If we just compare this, we can see that that's going to behave like an x cubed. It's going to essentially behave like an x cubed function over 2. So an x cubed function compressed, and it's going to have a positive leading coefficient. That's definitely going to be this one here. Okay, so that's going to match. So that's going to match C. And then looking at 31, number 31, do the same thing. We can do the limit as x approaches infinity of 2x to the power 4 minus x cubed plus x squared minus 1. All that stuff is not really relevant to this. I'm going to write this as negative x plus 2. And then I can see that comparing, looking at the highest powers in the numerator and denominator, I can see that this is essentially going to behave like negative 2x cubed function. Well, the negative 2x cubed function looks like it's going to be this one here. Okay, it's a negative cubic function, so that's going to be matching D. So this will match D. And then for 32, we can again do the same thing. For 32, it's going to be the limit as x approaches infinity of x to the power 4 minus 3x cubed plus x squared minus 1. And again, I'm going to move that negative to the front to make it easier to work with, and then compare these two powers. And by doing that, this is approximately equal to negative x squared. Okay, so it's going to behave essentially like a negative x squared function. It's going to be that one there. So by process of elimination, we could have gotten B, but it does match B.